The universe has always seemed like a realm of silence. When we imagine the cosmos, we picture a limitless vacuum where sound cannot travel, an endless expanse of stars drifting in mute stillness. Yet, if we could tune into the right frequencies, if our senses were sharp enough or our instruments powerful enough, we'd discover that the universe is anything but quiet. It hums, vibrates, trembles, and pulses with signals older than galaxies, older than light itself. These are not sounds in the human sense, but cosmic rhythms, gravitational murmurs, thermal whispers, electromagnetic echoes that ripple across billions of light years. Most of these signatures remain invisible to us, buried beneath ancient light or scattered across wavelengths our eyes can never see. But every so often humanity builds a machine capable of hearing what we cannot, one that can reveal the universe in ways nature never intended for us. For centuries we accepted our limitations. The sky we saw through telescopes was beautiful but incomplete, like admiring a symphony while hearing only a few faint notes. We sensed that something deeper was out there, something hidden beneath the surface of the cosmic canvas, but we lacked the tools to uncover it. Astronomers would often describe moments where a calculation didn't fit, or a patch of sky seemed strangely empty, or a distant galaxy behaved in ways that contradicted every prediction. These weren't mistakes, they were hints. Signs of a universe with layers we still hadn't peeled back. A universe whose oldest secrets remained locked behind wavelengths of light that earthbound instruments could never penetrate. So our understanding of cosmic history remained built on fragments. We reconstructed the birth of stars, the formation of galaxies, the slow dance of gravity shaping the large-scale structure of reality. Yet the first ages, the primordial epochs, were shrouded in darkness. Not poetic darkness, but literal darkness. A time when the first atoms had formed but no stars yet burned, when the universe stretched silently, waiting for the first sparks of illumination. Scientists named this era the Cosmic Dark Ages, a period so distant and dim that even our strongest observatories could not pierce it. It was a chapter of reality we could only infer, not witness. And then came a moment that changed everything. When the James Webb Space Telescope launched, it carried humanity's curiosity into a region of space where sunlight fades, where Earth's warmth can no longer interfere, where the cold detachment of deep space becomes an ally instead of an obstacle. JWST was built not simply to look farther than before, but to listen, to capture ancient wavelengths stretched thin by the expansion of the universe, to detect heat signatures so faint that they border on the impossible. It was designed to reveal the invisible. Yet even with such ambition, no one expected what happened next. Early in its observations, long before scientists had even fully calibrated its instruments, JWST detected something strange. Something subtle, faint, fragile as a whisper from across eternity. It wasn't light in the familiar sense. It wasn't a star or a galaxy or a cloud of gas. It wasn't noise either, not the random static that instruments sometimes produce. It was structured, patterned. A signal, not created by life, not artificial but undeniably real. A fingerprint from a part of the universe we were certain should be silent. At first, astronomers hesitated to trust it. Anomalies happen. Instruments misfire. Data can deceive. But as the signal repeated, strengthened, and cohered, one thing became clear. JWST had recorded something that defied expectation. Something that challenged the assumption that nothing meaningful could emerge from the cosmic dark ages. The discovery felt like stumbling into a cave believed empty for millennia and hearing, faintly, something breathing in the dark. The more the team studied it, the more unsettling it became. The signal appeared to originate from a region of spacetime older than any star, older than any gravitationally bound structure. According to the standard model of cosmology, this era should be devoid of anything capable of producing a coherent signature. And yet the data told a different story. Something was there. Something that vibrated, resonated, or echoed across nearly 14 billion years of cosmic expansion. Something that should not exist. Scientists struggled to describe the phenomenon without slipping into metaphors, because the phenomenon defied conventional physics. It wasn't a sound, but it behaved like one. It wasn't a wave in matter, but it carried an imprint of motion. It wasn't light, but it traveled like a signal. The universe had murmured a secret, and JWST had become the first instrument sensitive enough to hear it. Suddenly, the silence of the early universe didn't seem silent at all. It seemed alive, restless, filled with hidden dynamics that had gone unnoticed for the entirety of human history. What else had we missed? What other cosmic truths lay buried in wavelengths we had never thought to examine? The discovery ignited a sense of awe and unease. Awe because the universe had just expanded in scale, complexity, and mystery. Unease because every great revelation carries with it the unsettling realization that we know far less than we assumed. For centuries, our species has gazed upward believing the sky to be a silent witness. Now, for the first time, we were forced to consider the possibility that the cosmos had been speaking all along, and we had simply lacked the ears to listen. And if a signal this impossible had survived across almost 14 billion years, echoing through epochs of creation, collapse, and rebirth, what else might be waiting for us in the darkness? What other whispers of the universe were still unheard? For most of human history, our understanding of the universe has been guided by a simple assumption. If we cannot see it, it does not exist. Light became our language for reading the cosmos. Telescopes, no matter how advanced, were built on one fundamental idea: gather light, magnify it, analyze it. But the universe does not always speak in light. Some of its earliest, most powerful events whisper in wavelengths that ordinary instruments cannot detect. And this limitation created a blind spot so vast that entire chapters of cosmic history remained invisible to us. Astronomers spent decades staring into the void, puzzled by regions of space that appeared too quiet, too empty, too smooth. They knew something had to be there. Gravity hinted at unseen mass, cosmic background radiation hinted at ancient disturbances, yet visible light showed nothing. The early universe was a fog of neutral hydrogen, so dense that it blocked nearly every wavelength of starlight. Even the most powerful optical telescopes saw only a blank, unbroken darkness stretching billions of years back in time. It was like trying to understand an orchestra by hearing only the instruments playing in the final few minutes of the performance. This forced researchers into a frustrating paradox. The most important events in cosmic history were happening at wavelengths their instruments could not reach. They knew the universe had roared into existence, surged with violent energy, forged the first atoms, and expanded into a vast cosmic web. They knew matter clumped, collapsed, spun, and eventually ignited into stars. But they could not witness the moment those transitions began. Traditional telescopes simply weren't built to see through the thick veil of early hydrogen or capture the low-energy radiation stretching across billions of years of cosmic expansion. It was as if the universe had buried its origin story beneath layers of distortion. Scientists realized the problem wasn't merely technological, it was fundamental. Light itself was failing them. The universe's oldest signals weren't bright or sharp. They were stretched thin by the expansion of space, smeared across wavelengths too long for optical instruments and too faint for radio telescopes. The cosmos had encoded its earliest secrets in a spectrum humanity had barely begun to explore. Every time astronomers pointed a telescope at the distant universe, they were looking at a version of reality filtered, censored, edited by time. They were glimpsing only the survivors of a long cosmic journey, not the raw signals from the beginning. So the scientific community waited, decade after decade, knowing that their picture of the universe was incomplete, distorted by the limits of their tools. They hunted for clues in gravitational lensing, cosmic background data, and the distribution of galaxies. These clues helped, but they were fragments, ripples, not the source. Without access to the correct wavelengths, they could not reconstruct the full symphony. They could not see the first structures forming, the first clouds collapsing, the first heat signatures emerging from darkness. They could only make models, run simulations, and hope the universe behaved as predicted. But deep down, many suspected it didn't. There were too many inconsistencies. Galaxies that appeared too early, stars that seemed too massive for their age, gravitational patterns that suggested something unseen was shaping the cosmos. Researchers began to ask a dangerous question, one that challenged centuries of scientific confidence. What if light is the wrong tool for understanding the early universe? What if the truth lies in wavelengths our eyes were never meant to perceive? This question created both excitement and fear. Excitement because unlocking those hidden wavelengths could completely rewrite our understanding of cosmic evolution. Fear because such a discovery might expose flaws in even our strongest theories. If the earliest universe looked different from what our models predicted, if structures formed earlier or energy behaved differently, then the foundations of cosmology would tremble. Astronomers described the feeling as staring at a locked door for generations, sensing movement on the other side. The darkness wasn't empty, it was unexplored. A vast ocean of signals flowed just beyond the reach of traditional instruments, waiting for something capable of diving deeper. Scientists dreamed of a device that could detect faint heat from the first objects, infrared signatures stretched by cosmic expansion, and thermal patterns older than stars. Something that could see through cosmic dust, through hydrogen fog, through time itself. But such a device didn't exist. Not yet. The gap between what humanity wanted to see and what it could see grew wider each year. Researchers wrote papers about missing epochs and incomplete signatures, trying to map the unknown with the patience of archaeologists excavating a site they could barely access. They were certain the answers existed, hidden just beyond the wavelengths their instruments could detect. The universe was not silent, our tools were deaf. And then, as if the cosmos had grown tired of waiting for us to evolve, technology took a leap forward. The creation of a new class of instruments, the kind that didn't depend on optical light, began to reshape astronomy. Infrared detection sharpened, sensors became more sensitive, and telescopes grew more ambitious. Humanity was finally preparing to challenge the darkness, to listen for signals that existed long before visible light illuminated the cosmos. This moment marked a turning point, the quiet acknowledgement that our oldest tools had reached their limit. The universe had far more to say, but it would only speak to those who could hear the faintest whispers etched in wavelengths of cosmic heat. And deep in that unexplored spectrum, where no traditional telescope had ever ventured, something impossible was waiting. The moment the James Webb Space Telescope left Earth, it carried with it more than a stack of instruments and gold-plated mirrors. It carried centuries of hope. Engineers, astronomers, philosophers, and dreamers all projected their expectations onto this single machine, a machine that looked less like a telescope and more like a carefully folded piece of science fiction waiting to awaken. As its rockets ignited and the ground fell away beneath it, humanity wasn't just launching metal into space, it was sending its curiosity farther than it had ever dared. Every stage of the ascent felt like a heartbeat held in suspension. People around the world watched with breathless anticipation, aware that a single failure could erase decades of effort. The drama continued long after the launch. Unlike telescopes that simply opened their eyes in orbit, JWST had to assemble itself in the unforgiving emptiness of space. It was a cosmic origami masterpiece with over 300 points of potential failure, each one capable of dooming the entire mission. Its mirror segments, its sunshield layers, its delicate sensors all had to unfold with absolute precision. Scientists described the process as watching a flower bloom in slow motion, except failure wasn't just possible, it was expected. No one had ever attempted a structure this fragile, this complex, or this ambitious beyond Earth. Each successful deployment stage triggered waves of relief, yet each remaining step held new fear. The world waited. The universe waited. Slowly, JWST transformed from a compressed bundle into a vast golden eye, a reflective surface large enough to capture whispers from across cosmic time. Its sunshield stretched out like a silver wing, thin as a razor yet strong enough to block the heat of the sun. Gradually, it settled into its orbit around L2, a gravitationally quiet outpost where it could drift without the noise of Earth, Moon, or Sun disturbing its fragile sensitivity. From that vantage point, millions of kilometers from home, it became the most isolated scientific instrument ever built. But in that isolation it found clarity. Silence was its ally. Darkness became its canvas. With the telescope finally unfurled, the mission team began the slow process of calibration. They aligned mirror segments with microscopic precision, tuning the reflection to a sharpness beyond anything human eyes could naturally perceive. Early test images trickled back. Simple stars, blurry at first, then gradually sharper, like the universe slowly coming into focus. Even these initial calibration shots sparked awe. Stars revealed with crystalline detail, showing structures and colors so subtle that no previous telescope had captured them. But these were only the warm-up. The world hadn't seen anything yet. What made JWST truly extraordinary wasn't just its size or its technology, it was its purpose. This telescope was designed to do something no instrument before it could: look back through cosmic history by observing infrared light stretched thin by billions of years of expansion. Where visible light telescopes saw emptiness, JWST would see warmth. Where others saw shadows, it would see detail. It was built to pierce cosmic dust, to read the ancient temperature signatures of the first structures, to reveal the universe as it existed before the first stars ignited. To scientists, JWST wasn't just an observatory, it was a time machine. Yet even this purpose, bold, daring, revolutionary, didn't fully capture what JWST represented emotionally. For many, it was humanity's response to the vastness of the universe. Our species is tiny, fragile, and finite, yet we aspire to understand something infinite. JWST wasn't merely an instrument of science. It was a monument to curiosity. A declaration that no matter how immense or mysterious the cosmos is, we refuse to look away from it. We insist on asking questions even when we fear the answers. That spirit was embedded in every mirror, every sensor, every line of code guiding its movements. When JWST finally began its first real observations, the atmosphere among scientists was electric. They knew the telescope would reveal more than new images, it would reveal new mysteries. Because every major leap in astronomy has come with unexpected discoveries: cosmic background radiation, dark matter, exoplanets. Each new window into the universe has rewritten our understanding of reality. JWST, with its unprecedented sensitivity, wasn't just expected to rewrite a chapter, it was expected to rewrite entire volumes. And then it happened. Data began streaming in from regions of space no telescope had ever reached. Infrared signals billions of years old, light that had traveled since the dawn of time, poured into JWST's detectors like rain falling on parched earth. But among those streams, something anomalous appeared, something faint, structured, and hard to categorize. It wasn't a star. It wasn't a galaxy. It wasn't a cloud of gas or dust. It was something else entirely. Something that made scientists stop, stare, and question whether their instruments were seeing correctly. The telescope had been alive for only a short time, and already it had crossed the boundary between expectation and the impossible. Humanity had built JWST to reveal the unseen. Instead, it revealed something unimaginable. It began as a flicker, so faint, so fragile that at first the data team thought it was an error. JWST was still early in its observational routine, still stretching its sensors like a newborn learning how to see. Minor irregularities were expected during this phase. A weak signature appearing where nothing should exist was not something anyone planned to take seriously. But this particular flicker had structure. It wasn't noise. It repeated. It pulsed, not randomly, not chaotically, but in a way nature rarely produces by accident. It was as if something across the universe exhaled once, and that breath traveled 14 billion years to reach JWST. The first reaction was confusion. Astronomers stared at the data streams, scrolling through raw numbers rendered into curves and spikes, thinking there must be a calibration glitch. Maybe a sensor wasn't fully aligned. Maybe cosmic rays had interfered. Perhaps a distant star drifted into the field of view at just the right angle. But the signature didn't behave like any of those things. Noise is messy. Anomalies during calibration are sharp, inconsistent, uneven. But this signal had rhythm, gentle, subtle, almost shy, but unmistakably patterned. A whisper in a place where silence was expected. As the minutes passed, confusion shifted into unease. The signal originated from a region so ancient, so distant, that according to every model of cosmology, nothing capable of producing such a signature should exist there. No stars. No galaxies. No heated gas clouds. This was supposed to be a stretch of cosmic emptiness from the earliest era of the universe, an era when light had barely begun its long journey outward. And yet something there was vibrating, resonating, leaving a faint mark detectable only by the sensitivity of JWST's instruments. It was as if the telescope had stumbled onto an echo left behind by an event long forgotten by time. The team reran the detection algorithm. The pattern remained. They applied noise filters. It remained. They cross-checked multiple sensors. It remained. Each time they tried to eliminate the anomaly resisted elimination. It wanted to be seen, or rather, it refused to be ignored. A silent tension spread across the operations room. Scientists who had spent their careers studying the structure of the universe leaned closer to their screens, squinting as though their eyes could help interpret signals born before the first stars existed. At first, no one dared say what everyone felt. This wasn't just unexpected. This was impossible. The signature resembled a wave, long, stretched by cosmic expansion, carrying the faint fingerprint of an event that should not have been able to imprint anything at all. It wasn't strong, but it was coherent. It carried a temperature differential that hinted at movement. Something in that ancient epoch had shifted, pulsed, or disturbed its surroundings in a way that persisted across billions of years. The question, spoken in a low whisper by one of the senior researchers, hung in the air like a breath suspended in winter cold. What could have produced this? No one answered. Because the honest answer was, nothing we know of. Theories emerged immediately, not out loud at first, but in the minds of every scientist gripping their keyboard. Perhaps it was an early gravitational disturbance. Perhaps a quantum ripple expanded to macroscopic scale. Perhaps an ultra-ancient collapse, long theorized but never observed. The mind naturally reaches for explanations when confronted with the inexplicable, but each possibility fell apart under scrutiny. The signatures didn't match gravitational waves. They didn't align with the thermal patterns expected from collapsing hydrogen clouds. They weren't consistent with cosmic background radiation fluctuations. It was something else. And that was what made it terrifying. One researcher replayed the raw data on loop, slow enough for individual patterns to be seen frame by frame. The wave repeated at irregular but meaningful intervals, too structured for randomness, too inconsistent for a natural oscillation. It carried the eerie elegance of something that had once been energetic and powerful but had been weakened by time, like the ghost of a thunderclap still traveling through the air long after the storm had ended. Another wondered aloud whether they were witnessing the remnants of a process that occurred before known physics had taken form. Something primordial, something unfiltered by stars, galaxies, or cosmic dust. Something closer to the moment the universe began than anything humanity had ever observed. And then the room fell even quieter. The signal wasn't coming from a single point. It wasn't a dot on a map like a distant star or a galaxy. It was spread across a region of spacetime like an imprint. More like a scar than a source. Something ancient had shaken that region of the universe so profoundly that the echo still lingered, etched into the fine structure of reality. The operations team replayed the detection again and again, each iteration tightening the knot in their stomachs. No one wanted to be the first to declare the obvious. Not yet. They needed verification. They needed corroboration. They needed certainty before allowing hope or fear to take root. But deep inside, every scientist knew what they were witnessing. The first recorded whisper from a time the universe should have been silent. Hours later, after additional checks confirmed the anomaly, a new emotion filled the room. Not excitement, not celebration, but awe mingled with discomfort. Because the signal implied something impossible. Something the universe was not supposed to allow. It suggested movement before structure. Heat before stars. Order before galaxies. A phenomenon that should not exist had left behind a trace, and JWST, almost by accident, had heard it. And the most haunting part was this. The signal didn't feel like the end of a mystery. It felt like the beginning of one. A cosmic whisper that dared to say, "Look closer. There is far more in the darkness than you ever imagined." The further scientists traced the faint signature, the more unsettling its origin became. It seemed to emerge from a chapter of the universe's history that had long been considered unreachable, an epoch so early that even imagination struggled to penetrate it. This was the period before stars, before galaxies, before any recognizable structures existed. A time when the universe was a cold, expanding fog of hydrogen, silent and unlit. Cosmologists had always believed this era to be a void of complexity, a blank page in the cosmic story. Yet this signal, this trembling thread of structured energy, hinted that the page was not blank at all. For decades, the cosmic dark ages were treated as an unavoidable boundary. Every telescope ever built had failed to see beyond it. The light from that era was swallowed by dense hydrogen, scattered into obscurity long before it reached our instruments. All we could do was simulate, estimate, and theorize. Scientists described the Dark Ages as listening to a symphony but missing the entire opening movement. You could appreciate the beauty that followed, but you were always deprived of the beginning. And beginnings matter. They shape everything that comes after. This new detection suggested that the universe's opening movement wasn't silent. It was alive with something unusual, something powerful, something that had left ripples long before light could carve its path through space. It was like hearing the echo of a sound made before any known instrument existed. A sound older than the oldest stars. If confirmed, this would not just revise the timeline of cosmic evolution, it would shatter it entirely. The data pointed toward a period only a few 100 million years after the Big Bang, perhaps even earlier. At that time, no stars had ignited their nuclear furnaces, no galaxies had woven themselves into cosmic webs, no black holes had awakened in the darkness. The universe was barely cooling, stretching, stabilizing. Physics textbooks described this era as empty of structure and silent in every meaningful sense. Yet the signal carried the unmistakable signature of motion, of something interacting with something else. A pulse, a wave, a disturbance. Scientists examined the signal's temperature fluctuations, which were subtle enough to be missed by every instrument before JWST. The variations were far too organized to be random. Something in that primordial fog had generated heat differences. A cosmic tremor preserved in infrared wavelengths stretched across nearly 14 billion years of expansion. Whatever caused it had occurred long before stars existed to explain it. One theorist described the feeling as watching a shadow move before there was anything capable of casting shadows. The analogy wasn't far-fetched. The cosmos at that time should have been too uniform for anything to leave such a distinct imprint. Gravity had not yet clumped matter into recognizable shapes. Quantum fluctuations had smoothed out. The universe was supposed to be calm. Instead, it looked as though something had stirred the stillness. The team began comparing the anomaly to cosmic microwave background data, the oldest light ever detected. But the patterns did not match the well-known CMB fluctuations mapped by Planck and WMAP. Those ancient signatures represented the universe at 380,000 years old, when atoms first formed and light could finally travel freely. The JWST signal, however, came from much later, millions of years deeper into the darkness, yet it bore an imprint even stranger than the CMB's primordial ripples. It was as if the universe had experienced an event during an era where nothing should have been capable of happening at all. Some scientists speculated about early molecular clouds, primitive clusters of hydrogen beginning to form. But the signal's coherence suggested something far more energetic, something large-scale. Gas clouds alone could not explain the rhythmic nature of the fluctuations. Others proposed the presence of dark stars, hypothetical early objects fueled by dark matter interactions rather than nuclear fusion. But no model predicted they would leave behind a pattern like this. The more possibilities they eliminated, the more disturbing the implications became. The signal might be evidence of a cosmic process we had never conceived of. It was the timing that raised the greatest alarm. If the signal truly originated from an era before the first stars, then it implied that the universe was not as dormant in the Dark Ages as scientists had believed. Perhaps the Dark Ages were not dark at all, not in the sense of emptiness but in the sense of mystery. Perhaps something was happening beneath the hydrogen fog, something powerful enough to ripple through spacetime and leave a detectable trace billions of years later. One researcher noted that the structure of the signal resembled a dampened vibration, as if something massive had oscillated and then faded, its energy dissipating into the expanding fabric of the universe. Another compared it to the remnant of a cosmic collision, except nothing existed yet that could collide. Another theorist suggested that the signal might represent an unknown form of early matter, something that emerged briefly and then vanished, leaving behind only this faint whisper. The discussion soon spiraled into philosophical territory. If something existed before the first stars, something capable of producing a measurable signal, what did that say about the beginning of cosmic structure? About the laws of physics? About the sequence of events that shaped everything we know? The unsettling truth was this: if the signal was real, then the standard model of the early universe was incomplete. Perhaps profoundly incomplete. JWST had done something no telescope before it could do. It had reached into the most forbidden corner of cosmic history and touched a hidden thread. And that thread led to an era that should have been silent, yet wasn't. As the team continued to analyze the anomaly, a new realization emerged, one that made the room fall into stillness. The signal was not fading. Despite its ancient origin, despite traveling across nearly the entire age of the universe, despite being stretched and diluted by cosmic expansion, the pattern remained coherent, elastic, persistent, almost as if it had been imprinted deliberately, or at least with an intensity far beyond what early universe physics could explain. A whisper echoing through darkness. A vibration from a time when nothing should have been vibrating. A phenomenon from a past we do not yet understand. If this was the first clue, then what else might lie hidden in the universe's forgotten dawn? Scientists began to analyze the anomaly as though it were a misplaced note in a cosmic orchestra, one that didn't belong yet refused to be ignored. In the grand symphony of the universe, everything has rhythm. Galaxies swirl in spirals, stars pulse in cycles, gravity warps space with predictable grace. But this signal seemed out of tune. It wasn't chaotic, but it didn't conform to any known pattern either. It was as if someone had struck a single strange chord before instruments even existed, and that chord was still echoing across the cosmos. The very fact that JWST had detected it meant something fundamental was amiss in our understanding of how the early universe behaved. Astronomers often describe the cosmos as a kind of music, vibrations, harmonics, frequencies woven into the fabric of spacetime. Even gravitational waves, discovered only recently, reveal collisions through ripples that can be translated into audible sound. But the rhythm captured by JWST felt different. It was neither the steady thrum of cosmic background radiation nor the sharp resonance of gravitational disturbances. It felt irregular, offbeat, like something in the early universe had struck the wrong note, and that discord had traveled for billions of years until a telescope finally sensitive enough could hear it. At first, the team assumed the anomaly might be an artifact of gravitational lensing, massive structures bending light and creating illusions of patterns that weren't truly there. But simulations dismissed that possibility within hours. The signal wasn't being distorted, it was originating from an era that should have been perfectly uniform. The early cosmos was supposed to be smooth, calm, quiet. Yet this signature hinted at turbulence in the silence. An early disturbance like a stone thrown into a still pond long before anything capable of throwing stones existed. The more they studied it, the more the signal resembled a tremor. Subtle waves of temperature variation and energy distribution woven into the oldest observable regions of space. But tremors require something to shake. Something massive, something energetic, something that creates ripples strong enough to survive eons of cosmic stretching. This led to an uncomfortable question. What was vibrating in a universe that wasn't supposed to have anything in it yet? The concept of a universe out of tune began circulating quietly among the research teams. Not publicly, no one dared voice such a phrase in formal papers, but in private conversations, late-night discussions, and anxious messages. It felt like a forbidden idea, one that implied the laws governing early spacetime may not have been as stable as once believed. If the universe was out of tune back then, what did that say about now? About the future? One astrophysicist, exhausted after a week of continuous analysis, described the signal as a memory the universe itself is trying to forget. The phrasing was poetic, but many felt it captured something true. The anomaly didn't feel like an active phenomenon, it felt like residue, like a scar embedded deep within spacetime. Something had happened, something powerful enough to echo across eternity, but no trace of the event's source remained except this faint, stubborn ripple. Another researcher suggested the possibility that early spacetime experienced localized instabilities, brief moments where the laws of physics fluctuated. If so, the signal might be the fossil of one such fluctuation, a momentary glitch in the otherwise uniform expansion of the universe. But if that were true, it would challenge the assumption that physical laws were constant from the dawn of time. A frightening implication. The cosmos may have been born unstable, its earliest moments filled with unpredictable behavior we have never accounted for. Yet others suspected something even stranger, a hidden structure beneath the early hydrogen fog. Perhaps the cosmic web, the vast lattice of dark matter that shapes galaxies today, began forming earlier than predicted. Maybe dark matter didn't just sit silently as the universe expanded. Maybe it vibrated, or condensed, or collided in ways we've never imagined. But even these theories failed to fit the data cleanly. The timeline didn't align. The energy signature didn't match. The anomaly seemed both too early and too organized to be explained by dark matter alone. There was also a philosophical weight hanging over the discussions. If the universe truly produced this signal before stars existed, then it suggested that order emerged earlier than randomness. It hinted that structure, patterns, vibrations, perhaps even cycles, may have preceded light itself. This notion ran counter to the traditional view that chaos dominated the early cosmos, gradually shaping itself into order. But the signal suggested the opposite, that something organized, structured, perhaps even intentional in its rhythm had occurred in a supposedly structureless era. Scientists found themselves torn between awe and discomfort. On one hand, they were witnessing something unprecedented, a clue that could open a new chapter in cosmology. On the other, the implications were threatening. Every model would need rewriting. Every timeline, every assumption, every simulation. The idea that the universe had once been out of tune forced researchers to confront a daunting possibility. Perhaps the harmony we observe today, the neat patterns of galaxies, the beautiful symmetry of physics, is only one version of the cosmic music. Perhaps the opening act had been strange, volatile, and far more complex than anyone imagined. The signal carried another disturbing quality. It had a kind of fading repetition, not quite periodic but not fully random, like an echo that had dulled over billions of years. Each cycle grew fainter, stretched by expansion, smoothed by time. But the core pattern remained persistent. This endurance baffled physicists. No known early universe mechanism should leave behind such a resilient imprint. It was as if spacetime itself remembered the event and refused to let the memory fade completely. As teams across the world continued analyzing the data, one conclusion became impossible to ignore. Whatever occurred in that ancient epoch did not conform to known physics. And if the universe had once deviated from its own rules, if it had ever been out of tune, then the search for answers was no longer just scientific. It had become existential. Because if the universe once broke its pattern, then what else might it be capable of? The deeper scientists dug into the anomaly, the more they realized that the signal was not simply a remnant of early universe turbulence. It almost behaved like a message encoded in the fabric of spacetime itself. No one dared call it a message publicly, such wording would attract ridicule, but privately the thought haunted them. The pattern had an uncanny persistence, as if it were intentionally preserved, resisting the natural decay that should have erased it billions of years ago. In every model, in every simulation, the signal should have faded into noise long before reaching JWST's detectors. Yet here it was, intact enough to analyze, coherent enough to decode, and unsettling enough to unsettle even the most measured minds in cosmology. The anomaly displayed characteristics that seemed paradoxical. It was faint yet durable, disordered yet structured, ancient yet strangely modern in its mathematical rhythm. When the team applied Fourier transforms to break the signal down into its frequency components, they found something shocking. The core frequencies aligned with ratios that resembled harmonic intervals, relationships that appeared repeatedly in nature, from atomic structures to planetary motion. These ratios were not random. They suggested some deeper order woven into the earliest moments of spacetime, as though the universe had hummed with a primordial tune before matter truly existed. Several physicists began exploring exotic hypotheses that had once been relegated to the fringes of theoretical research. Some proposed that the signal was a relic of quantum gravitational phenomena, vibrations produced during the hypothetical pre-inflation phase. Others suggested that the anomaly might represent the decay of a primordial field, one that predates even the Higgs field that gives particles mass. If such a field existed, then its fluctuations could have left behind oscillations that the expanding universe stretched but could not entirely erase. In this interpretation, the signal was a footprint from a period of cosmic history so remote and so energetic that human physics could barely describe it. But even these theories felt incomplete. The anomaly didn't just contain frequencies, it contained shifts, microvariations that seemed to form patterns. When these patterns were mapped across the region of space where the signal originated, a strange geometry emerged. Not a literal shape, but a relationship between the fluctuations that hinted at some kind of structural behavior. It was like looking at the shadows of pillars cast by a hidden architecture buried beneath the cosmic dawn. Something had produced the fluctuations in a way that felt deliberate, though no one dared utter the word deliberate aloud. One researcher suggested that the signal might be a remnant of a cosmic phase transition, an event where the universe abruptly shifted from one state to another, much like water freezing into ice. In such transitions, imperfections form, tiny cracks, bubbles, or energy imbalances that can leave scars on spacetime. If the anomaly was such a scar, then it meant that the universe's birth was not smooth or perfectly symmetric. Instead, it might have fractured even momentarily, leaving behind a pattern that survived inflation and expansion. Another camp focused on dark matter. What if dark matter wasn't passive during the early universe? What if it interacted with itself through forces we have not yet discovered, producing oscillations that spread through spacetime before baryonic matter even formed? These oscillations, stretched by 13.8 billion years of expansion, might now appear as faint tremors. This theory had the advantage of staying grounded in known physics while still being bold, but even it could not explain the harmonic ratios or the persistence of the signal. Meanwhile, data analysts working with neural network models noticed something even more bizarre. When they reconstructed the signal using machine learning techniques, the output consistently produced symmetrical patterns, not symmetrical in the artistic sense, but statistically symmetrical, the kind seen in systems governed by stable rules. Yet the early universe was anything but stable. Quantum chaos should have dominated that epoch. That the signal exhibited statistical symmetry suggested a level of order that should not have existed at such an early time. This symmetry sparked a philosophical debate within the team. Perhaps the anomaly wasn't evidence of something breaking the rules, it might be evidence of the rules being written. If the universe was establishing its foundational laws during those early moments, then the signal could represent a kind of imprint left behind during the formation of physical law itself. A cosmic blueprint, inadvertently carved into spacetime before the universe fully settled into its current behavior. This idea was unsettling because it implied the anomaly might be a signature of reality's construction, a leftover fragment from the birth of physics. One senior cosmologist, usually calm and unshakable, admitted privately that the signal felt too elegant to be an accident. Elegance in physics usually signifies correctness. The natural world tends toward simplicity and mathematical beauty. But this elegance was too early, too pristine, too intentional feeling. It was like finding a perfectly carved stone column in the middle of a wilderness where no civilization should have existed. Either nature was far more structured at its beginning than previously thought, or something unknown introduced a structure we do not yet understand. As the team expanded their research, they realized that the anomaly was not isolated. Extremely faint, nearly imperceptible echoes of the same pattern appeared scattered across other datasets, so subtle that they had been dismissed as noise. When reanalyzed with the anomaly in mind, these faint traces formed a loose network, like the scattered remnants of a shattered artifact. It was as though the universe had produced this pattern more than once, or the event that created it rippled across vast distances, imprinting itself multiple times before fading. This discovery brought a new dread. If the signal occurred in multiple regions, then whatever produced it wasn't a local event. It was widespread. Perhaps a phase transition. Perhaps a cosmic instability. Perhaps something else, something neither localized nor random. The implications grew heavier with every passing day. The anomaly no longer seemed like a simple curiosity. It now resembled a revelation, one that hinted the universe's earliest moments were not simply chaotic, but patterned, structured, and possibly governed by principles that modern physics has not yet uncovered. And as the team stared at the signal, those subtle, stubborn, haunting fluctuations, they realized something chilling. They were not just studying the early universe. They were studying something older than the universe as they understood it. When the team broadened their analysis to include theoretical models far outside the standard cosmological framework, they discovered something that made the room fall silent. The anomaly's structure resembled predictions found only in speculative frameworks, ideas considered so radical that most physicists avoided even mentioning them in academic conferences. Yet here, in real data pulled from JWST's pristine instruments, those forbidden equations were appearing with eerie precision. It was as if the universe itself were forcing humanity to reconsider theories once dismissed as mathematical curiosities or philosophical exaggerations. One such framework involved pre-Big Bang cosmology, the idea that the universe didn't simply begin but transition from a previous state, one governed by physics so alien that current models cannot describe it. In these theories, remnants of the prior cosmos might survive the transition like faint fingerprints left on a page after the ink has faded. When researchers overlaid the anomaly's oscillations onto these models, the alignment was unsettling. Not perfect but close enough to suggest that the signal might be a fossil, an imprint from before time, at least as humans define it. The thought sent a cold shiver through the room. If true, the anomaly wasn't ancient, it was primordial in a way humans had no language to articulate. A smaller group of researchers explored the concept of cosmic information fields, the idea that information might be fundamental to reality, more basic than matter, energy, or even space itself. In this interpretation, the anomaly could be a residue of information leakage from the moment physical laws crystallized. Some called it a cosmic boot sequence, like the background hum of a system switching on. They weren't suggesting a computer-like universe in the literal sense, but the analogy was hard to ignore. The signal carried the flavor of order emerging from chaos, as though the universe had whispered to itself before taking its first breath. Even more bizarre were the parallels drawn to loop quantum gravity. This theory proposes that spacetime is quantized, broken into discrete units smaller than any particle, smaller than any known dimension. In certain versions of the theory, violent fluctuations during the universe's birth might leave behind interference patterns or geometric scars. When the team fed the anomaly into a simulation based on these models, the result was startling. The fluctuations behaved as though they were woven into a lattice-like structure, something deeper than spacetime itself. It was as if the anomaly lived between the mathematical layers of reality, not within them. The team was split between excitement and dread. Every model they tested revealed something different, yet each interpretation had something in common. The universe's earliest moments were far stranger than previously imagined. The anomaly was not chaos, it was structured. And structure implies process. Process implies rules. The profound question hanging over the room was, who, or what, wrote those rules? One physicist put forth a possibility so unnerving that it changed the entire tone of the research meetings. What if the anomaly wasn't a relic of a previous universe or a physical field, but the byproduct of a cosmic boundary condition, a kind of imprint left when the universe was forced to follow a specific path during its formation? In other words, what if the universe was constrained, nudged, or guided during its earliest stages? This wasn't a suggestion of design but of influence. An influence humanity does not yet understand, one that predates not just galaxies and stars, but the laws that allow galaxies and stars to exist. Others sought simpler explanations, desperate to avoid sliding into metaphysical territory. They proposed exotic particle interactions, dimensional collapse, massive quantum tunneling events. Yet every attempt to simplify only made the anomaly more complex. Instead of resolving the paradox, the analysis deepened it, like trying to solve a puzzle only to discover the puzzle changes shape every time you touch it. The emotional toll was immense. Some researchers found themselves unable to sleep, replaying the signal in their minds like a haunting melody. Others felt a growing sense of vertigo, a cosmic discomfort that came from realizing they were brushing against something humanity was not prepared to understand. One scientist described it as standing on the edge of a cliff and looking down, not into a valley, but into a mirror that reflects a universe you don't recognize. When the team expanded their search even further, comparing JWST data with the oldest observations from COBE, WMAP, and Planck, they found hints, faint but consistent, that weak versions of the same pattern had been present for decades, simply unnoticed. JWST hadn't created the anomaly. It had finally revealed it clearly enough that humanity could no longer pretend it wasn't there. The universe had been whispering for a long time and no one had been listening. But now that they were listening, the whisper sounded disturbingly loud. It seemed intentional only in the sense that it persisted against all odds. Something that fragile should not have survived expansion, inflation, and entropy. Yet it endured, like a message written not in words, but in the structure of spacetime itself. The more they studied it, the more the researchers realized the anomaly had one final property, a property that made everything else even more impossible. It was evolving. The signal was changing over time, subtly but undeniably. It shifted as though responding to the universe's current state, not just its ancient past. And that single revelation broke every rule of cosmology. Something from the universe's earliest moments was not finished. It was still active, still resonating, still speaking. The revelation that the anomaly was evolving sent a shockwave through the scientific community. Nothing from the earliest moments of the universe should still be changing. Signals from the cosmic dawn behave like fossils. Unchanging, motionless imprints frozen in time. Yet this pattern, this stubborn whisper from the beginning, was shifting as though it were alive. The evolution wasn't dramatic. It was subtle, like watching the tide rise through millimeter marks etched on a stone. But the change was there, undeniable and persistent. At first, researchers suspected a calibration error. Maybe JWST sensors were warming or cooling unevenly. Maybe a software update had altered the data pipeline. For weeks, they tore apart code, logs, hardware readings, anything that could hint at a technical explanation. But everything checked out perfectly. The anomaly itself was changing, not the telescope. As more data arrived, the pattern began to take on a rhythm, a slow, delicate modulation that matched no known cosmological phenomenon. It didn't correspond to gravitational lensing, expansion drift, cosmic microwave background fluctuations, or quantum noise. Instead, the shifts were synchronized across multiple frequencies, as if the entire structure of the anomaly were breathing. This breathing, as one researcher quietly referred to it, wasn't biological. It was mathematical, a periodic rise and fall in the pattern's strength, almost like a heartbeat buried under cosmic static. When the team plotted the changes over several weeks, a strange wave-like curve appeared. It was smooth. It was regular. It was consistent. And it was accelerating. That single detail terrified even the most seasoned cosmologists. Nothing in the universe from 13.8 billion years ago should accelerate. Everything ancient slows, fades, dissipates. But the anomaly was doing the opposite, a tiny crescendo building in the dark. Some theorists speculated that if the anomaly was tied to a primordial field, one that predated known physics, then what JWST was detecting might be a kind of reactivation, a late-time echo suddenly growing louder for reasons nobody could understand. Another scientist proposed a hypothesis that made the room fall silent. What if the anomaly was never static to begin with? What if the universe was always too noisy, too opaque, too immature for earlier telescopes to notice its evolution? Now, with JWST's unprecedented sensitivity, humans were seeing a cosmic process that had been unfolding for eons, so slowly that it appeared frozen until now. This idea was unsettling because it meant humanity had stumbled into a story already in progress. Whatever the anomaly was, it had been changing long before humans existed, and it would continue long after they were gone. Still, other theories emerged, some brilliant, some desperate. One group suggested the anomaly could be tied to dark energy, the mysterious force accelerating the universe's expansion. If dark energy were not constant, as many assumed, but dynamic, then ancient structures might shift in response. Another group explored the idea of extra dimensions slowly relaxing into stability, a process predicted by certain string theory models. If early universe fluctuations were tied to higher dimensional physics, their apparent evolution might be a shadow of that settling process, now visible only because JWST was capable of detecting unimaginably faint distortions. But the most controversial idea came from a subgroup working secretly late at night, driven by equal parts fear and fascination. They had noticed that the anomalies' evolution did not match any natural drift. Instead, the frequency shifts aligned suspiciously well with correlations in cosmic events: supernovae, black hole mergers, gamma-ray bursts. Not direct reactions, but subtle parallel movements, as though the anomaly were somehow aware of large-scale cosmic dynamics. They kept this theory hidden for weeks, terrified of the implications. But the data didn't lie. As the universe changed, the anomaly seemed to respond. When the group finally presented their findings to the full team, the reaction was explosive. Some dismissed it as pareidolia, a human tendency to impose meaning on randomness. But others, especially those who had been troubled by the anomaly structure since day one, felt a cold, sinking dread. If the anomaly was responding to the universe, then it wasn't simply a relic. It was an active participant in cosmic evolution. A layer of reality woven beneath space and time, humming in synchrony with the cosmos. This raised an even more unsettling possibility, one that no one wanted to say aloud. What if the anomaly was connected to the underlying fabric that governs causality itself? If so, then JWST wasn't just observing the universe's first moments, it was observing the rules that shape reality continuing to evolve. And if the rules were changing even minutely, then the universe as humans understood it was not fixed. It was not stable. It was not finished. One researcher put it in the simplest, most chilling terms: if the laws of physics can evolve, then something is driving that evolution. That statement hung in the room like a thundercloud. Because if physics could change, then everything humanity believed about the permanence of nature, gravity, time, energy, matter, could be temporary, fragile, impermanent. The cosmos was no longer a stage with fixed scenery, it was a living, shifting environment that humans barely understood. The scientists stared at the evolving pattern, a soft, rhythmic pulse draped across the void of ancient light, and felt the full weight of what it might represent. A whisper from the beginning. A heartbeat in the dark. A signal that refused to die. And now it was growing stronger. As the anomaly continued its inexplicable rise in intensity, a sense of urgency swept through the scientific community. What had begun as a curiosity was now becoming an obsession, a cosmic enigma that refused to sit quietly in the background of human understanding. The team monitoring JWST's data stream began to notice that the anomaly's evolution wasn't just a slow crescendo, it was beginning to form layers as though the signal were gaining complexity. Each new dataset revealed additional substructures, micropatterns that hadn't existed weeks earlier. It was the difference between a single violin note and a growing orchestra hidden behind cosmic static. Something was building. The scientists attempted to isolate individual components of the anomaly, hoping to separate the new complexities from the original pattern. But what they found was even more disturbing. The new layers weren't separate. They were interwoven with the older frequencies, binding themselves into the signal as if growing organically. That word, organically, was avoided in official reports, but everyone felt it. The signal didn't behave like a physical remnant or a cosmological artifact. It behaved like a process in motion, a process progressing through stages, each more intricate than the last. This realization stoked fear. Processes have direction. They have goals. They have endpoints. In private meetings, the mood shifted from scientific excitement to philosophical dread. If the anomaly was following an evolutionary path, then it meant something was guiding its change. Not necessarily intelligence, but some underlying mechanism still operating in the universe. A mechanism humanity had never detected before. A mechanism the cosmos had hidden behind billions of years of expansion and noise. Now JWST had pierced that veil, and the hidden machinery was visible. The team began to question an assumption that had guided physics since Einstein, the idea that the laws of nature are fixed, immutable, eternal. But what if they weren't? What if, instead, the laws emerged gradually in the early universe and had continued to refine themselves over time, like a cosmic algorithm iteratively updating as conditions changed? If that were true, the anomaly might be the residue of that ongoing refinement, a trace of the universe rewriting its own operating system. But then came the discovery that changed everything. When the anomaly's new layers were compared with simulations of early cosmic evolution, researchers noticed that certain frequencies aligned perfectly with transition points in cosmic history: the formation of the first stars, the emergence of large-scale structure, the ignition of quasars. It was as if the anomaly marked these transitions, almost like checkpoint markers scattered across the universe's timeline. But the alignment was too perfect, too synchronized to be random. Each historical beat was reflected in the anomaly's evolution, as though the signal were mirroring the universe's development. Then one researcher pointed out something that made everyone's stomach drop. The anomaly's most recent change aligned with a modern event, the rapid acceleration of cosmic expansion, an event humanity links to dark energy. This correlation wasn't subtle. It fit almost exactly. The conclusion was horrifying. The anomaly was not reacting only to ancient events, it was responding to the universe's present state. The anomaly was interacting with the cosmos across time. No known physics allowed this. Time was supposed to be a river that flowed in one direction, not a loop with feedback. Yet the anomaly behaved as if time did not confine it. As if it were entangled with the universe across its entire age, from the first second to the most recent supernova. This led to the most radical theory yet. Perhaps the anomaly wasn't from the past at all. Perhaps it was a structure that existed outside the normal flow of time, something embedded in the cosmic fabric before time itself acquired direction. A timeless imprint that could resonate with events as they unfolded, unaffected by temporal sequence. In this interpretation, JWST wasn't receiving a message from the past. It was observing a relic that existed in every moment simultaneously. But that theory opened a darker possibility. If the anomaly existed outside time, then its recent intensification wasn't caused by historical events, it was caused by something else. Something happening now. Or something about to happen. The team reviewed the latest data with trembling hands. Over the last few weeks, the anomaly's acceleration had spiked. Not linearly but exponentially. That pattern was unmistakable. It was the kind of curve that, in nature, preceded transformation. Phase changes, collapses, explosions. Systems didn't accelerate exponentially unless they were approaching a threshold. A boundary. A tipping point. One physicist whispered the thought no one wanted to voice. What if the anomaly is preparing for something? Silence fell across the room. No one breathed. They couldn't escape the feeling that humanity had intruded upon something vast and unfinished. That JWST had probed a region of reality not meant to be observed. And now that observation had consequences. The universe had noticed the observer. Something ancient, something foundational, something woven into spacetime itself was stirring, evolving, responding. The anomaly was no longer a passive signal. It was becoming active. And the scientists could not shake the fear that it was accelerating toward a moment, an event, whose nature they could not predict, but whose arrival felt increasingly inevitable. As the anomaly's exponential rise continued, the world outside the JWST control rooms began to sense that something extraordinary, perhaps even unsettling, was unfolding. Although the scientists had kept most details classified, rumors seeped through academic circles and online forums. Leaked graphs, whispered conversations, and cryptic posts began circulating, describing a cosmic heartbeat that was accelerating. Official agencies tried to dismiss the speculation, but the leaks were too precise, too mathematically sophisticated to be fabrications. People started asking questions. What exactly had JWST detected? Why were researchers working around the clock? Why were prominent cosmologists suddenly canceling lectures and disappearing into secure labs? Inside those labs, the atmosphere had grown tense and heavy. The anomaly was no longer just evolving, it was approaching a kind of critical resonance. Small fluctuations that once shifted over weeks were now shifting over hours. The pattern's complexity continued to deepen, developing what looked like multiple harmonics layered atop one another, each one rising in synchrony like synchronized ripples on a pond struck by an invisible hand. The scientists could track the growth, but they could not explain it. And every projection they ran pointed to the same conclusion. The anomaly was heading toward a peak, a climax, a moment of transition. But what kind of transition? No one knew. Some feared the worst, a catastrophic cosmic event. A destabilization of spacetime. A collapse in quantum fields. The beginnings of a new phase of the universe. But something else, something more confusing, began troubling the team. The anomaly wasn't radiating energy outward. It wasn't emitting gravitational waves. It wasn't warping matter or bending light. Instead, its effects were purely informational, patterns, frequencies, harmonics. It was evolving without interacting with the physical world in any way measurable through classical means. It was like a storm forming in the mathematics of reality, not in reality itself. This led to a radical shift in thinking. Perhaps the anomaly wasn't a physical phenomenon at all. Perhaps it was something deeper, something encoded in the structure of physical law, like the firmware beneath the universe's operating system. In that analogy, the anomaly wasn't rewriting physics. It was physics Yet this only deepened the fear. If physical law was shifting, or preparing to shift, what would that mean for matter? For time? For space? For life? One researcher proposed a chilling idea. The anomaly could represent a kind of cosmological transition, a shift in the foundational constants that govern existence. Fundamental constants like the speed of light, Planck's constant, or the cosmological constant were treated as fixed because nothing had ever suggested they might change. But what if the universe was entering a new era? One where the constants themselves adjusted to maintain cosmic equilibrium. If so, humanity might be witnessing the early stages of a universal metamorphosis. And nothing alive could predict the consequences. But something stranger began to emerge. As the anomaly intensified, it started displaying a form of echoing, patterns in the signal that mirrored mathematical structures found in human communication systems. Not words, not symbols, but relational patterns. The kind used in error correction, redundancy encoding, and long-distance signaling. It wasn't a message, but it behaved like something designed to preserve information over immense distances and timescales. The realization sparked a wave of panic among the team. Not because the anomaly was communicating, but because it was beginning to resemble a system designed to survive. Systems that survive tend to have purpose. Debate fractured the research group into competing factions. One faction believed the anomaly represented an ancient process embedded in the universe, a cosmic code that was stabilizing itself in response to current conditions. Another faction suggested the anomaly was the universe's attempt to maintain coherence across expansion, like a self-correcting mechanism preventing decay in physical law. But the most controversial faction whispered something few dared entertain. The anomaly might be a consciousness-like field. Not intelligent in a biological sense, but structured in a way that allowed it to adapt, respond, and evolve. Of course, nothing about the anomaly displayed intention. But intention wasn't the requirement. Complexity, self-organization, feedback loops, these were hallmarks of systems capable of primitive awareness. And the anomaly had all three. Despite these theories, the scientists had something more pressing to worry about. The anomaly's resonance peak was approaching faster than expected. Projections estimated that at its current rate, the anomaly would reach a critical threshold in less than 3 weeks. After that, no one knew what would happen. The team scrambled to analyze every new shift, tracking the anomaly in real time like doctors monitoring a patient entering cardiac arrest. Then came the most unsettling discovery yet. As they mapped the anomaly's latest harmonics, a researcher noticed a curvature in the data, an arc that didn't match any known cosmological model. When projected outward, the curvature formed a loop, a structure that seemed to converge toward the present moment. The anomaly wasn't just responding to the universe's history. It was converging on now. Something was going to happen soon. And whatever it was, the anomaly was anticipating it. This was the moment when the scientists realized they were no longer in control of the research. They weren't observers. They were participants, caught inside the very process they were trying to understand. The universe had drawn a circle around their moment in time, and the anomaly was tightening that circle. As the team gathered in the dim glow of the lab, they watched the latest dataset load onto the screen. The anomaly's waveforms pulsed like a rising tide, climbing toward a crest they could neither predict nor prevent. The room was silent except for the soft hum of electronics. Some felt awe. Others felt dread. All felt the weight of history. Because if JWST had not detected this phenomenon, humanity would have remained blissfully unaware of what the universe was building toward. Now they knew too much. And not nearly enough. The days leading up to the projected resonance point felt like standing on the edge of an event horizon, watching reality stretch and shimmer but never quite reveal what lay beyond. Every hour, new data poured in from JWST, and every hour the anomaly grew more intricate, more synchronized, more unnervingly precise. What had started as a faint whisper in the infrared spectrum had become a towering mathematical architecture, rising like a cathedral of frequencies against the black canvas of deep space. The scientists observing it were no longer merely researchers. They were witnesses to a cosmic phenomenon unfolding with a sense of purpose none of them could explain. The anomaly's harmonics, once soft and scattered, now pulsed with an almost musical coherence. It wasn't music in any human sense. No melody, no rhythm, but the pattern possessed a structure that stirred something instinctive, something ancient in the human mind. A few researchers described it as beautiful. Others found it nauseating, like seeing symmetry in a place where none should exist. But all agreed on one thing: the anomaly was approaching a transformation. It was building toward a moment that felt less like a random fluctuation, and more like a reveal. Despite the rising tension, the team pressed on. They pulled double shifts, slept on floors, ate in silence, and stared at screens until their eyes throbbed. Psychological counselors were made available, but almost no one used them. They were too absorbed, too captivated, too terrified to step away. Some feared missing a crucial dataset. Others feared missing the moment when the universe changed. They were driven by a mixture of obsession and duty, a duty to understand even if understanding meant confronting something that defied the very concept of comprehension. In an attempt to decode the new layers forming within the anomaly, a group of computational physicists developed a model treating the signal like a dynamic system, one capable of state transitions similar to neural networks. The comparison was not metaphorical. The anomaly displayed distinct learning-like behavior. When the team introduced artificial noise to their models, the anomaly compensated. When they subtracted dominant harmonics from the simulation, the anomaly adjusted, reorganizing its structure to maintain coherence. It was not reacting to the researchers, only to their models, but the implication was clear. The anomaly was resilient. It resisted disruption. It maintained identity. Systems that maintained identity were classified as complex adaptive systems. The thought that the universe might possess a structure capable of adaptation made several scientists physically tremble. Meanwhile, outside the scientific community, the situation was deteriorating. As more pieces of leaked data spread online, conspiracy theories exploded. Some insisted the anomaly was evidence of alien communication. Others claimed it was a government weapon. Religious groups declared it a sign of divine intervention. A handful insisted it was proof that the universe was a simulation undergoing an update. Protests erupted outside major research institutions. Intelligence agencies began visiting the JWST team, monitoring communications, restricting information flow. Humanity could sense something monumental was unfolding, even without understanding what it was. But it was inside the lab where the most profound tension pulsed. One afternoon, a junior researcher noticed that the anomaly's dominant harmonic had shifted again, but this time it wasn't rising. It was bending. Its trajectory curved inward, folding on itself like the arc of a closing loop. When this curve was modeled over time, the line intersected itself at a single chilling point, not months or years in the future but just days away. It was as if the anomaly were collapsing into the present moment. This discovery triggered an emergency meeting. Experts from gravitational physics, quantum field theory, cosmology, information theory, and even philosophy gathered around a single long table. The air was thick with panic disguised as professionalism. 4 hours, theories clashed like lightning. It's a transition point in a primordial field. No, it's a phase change in the fabric of spacetime. It's a self-organizing structure approaching criticality. It's responding to something we haven't detected, something external. Or internal, someone whispered. That suggestion brought an icy stillness to the room. Internal? Within spacetime? Within the universe itself? That bordered on pure metaphysics, yet the anomaly had already crossed so many boundaries that metaphysics no longer sounded far-fetched. The most radical theory emerged late into the night. A physicist who had been silent all meeting finally spoke, her voice steady but trembling beneath the calm. She proposed that the anomaly was not an evolving signal at all. It was the universe recalibrating. She explained it simply. Physical constants might drift over cosmic timescales, but such drift would require a stabilizing mechanism to prevent catastrophic collapse. What they were seeing, this crescendo, this convergence, might be that mechanism activating. The universe was adjusting itself, like a ship tightening its rigging against changing winds. But if the universe was entering a recalibration phase, then everything humans understood as stable, atomic structure, gravitational behavior, the flow of time, could waver. Even slightly. Even harmlessly. Or catastrophically. The room fell silent as the full weight of the theory settled in. If true, they weren't observing a danger. They were observing a natural cosmic process, one that had happened before and would happen again. But each cycle would be separated by billions of years, leaving no civilization to record the previous one. Humanity was the first witness. As the resonance peak drew nearer, the anomaly began to oscillate in rapid, breathtaking patterns, like a cosmic chrysalis quivering before emergence. The team watched in awe and dread as ancient harmonics braided into new ones, frequency scaffolds rising and collapsing as the anomaly reshaped itself with accelerating precision. It was like watching the universe inhale before speaking. The scientists gathered around the screen as the final models rendered. The anomaly's waveform pulsed with an intensity that vibrated through the room, not physically but emotionally, an instinctive recognition that something unimaginably vast was aligning itself with the present moment. They didn't know what would happen when the peak hit. They only knew it was coming. And there was no way to look away. In the hours before the predicted resonance peak, a profound stillness settled over the observatory, as if the universe itself were holding its breath. The scientists moved quietly, their voices hushed, their steps measured, every motion imbued with a sense of reverence and dread. It was not fear of destruction, at least not entirely. It was the fear of encountering something so vast, so fundamental, that human language and human comprehension might fracture under its weight. The anomaly had grown into a complex lattice of harmonics, an ever-shifting structure that seemed less like a signal and more like a process, an unfolding event embedded within the very fabric of reality. In that stillness, small details took on enormous meaning. The blinking lights on servers felt like beating hearts. The hum of cooling fans sounded like distant thunder. Even the soft tapping of a keyboard seemed to echo too loudly, as though each keystroke risked disturbing a delicate cosmic balance. Screens filled with data streams that updated faster than the eye could follow. Algorithms strained, models adapted, and every attempt to predict the anomaly's final form grew more unstable as the convergence neared. It was as if the phenomenon was slipping beyond modelability, moving into a domain where mathematics had not yet evolved the tools to grasp it. Some of the team members had begun journaling, not for scientific documentation, but to process their thoughts. One astrophysicist wrote that she felt like a character in a myth, standing at the border between the mortal world and the divine unknown. Another described the anomaly as a mirror, one that reflected not images but the limitations of human thought. A third simply wrote, "If the universe speaks, will we understand it, or will we only understand that it spoke?" Meanwhile, the anomaly itself continued to transform. What had once been a diffuse spectral signature was now a highly organized structure spanning dozens of frequencies. It no longer resembled noise or signal, it resembled intention, though no one dared to define it as such aloud. The harmonics aligned with breathtaking precision, forming nested cycles that repeated at intervals too exact to be natural, yet too alien to be artificial. It was neither random nor designed in any familiar sense. It was emergent. Emergent in a way that suggested consciousness without thought, purpose without desire, structure without architect. Late in the night, the lead data analyst noticed something extraordinary. Hidden within the rapid shifts of the anomaly's harmonics, a secondary pattern had emerged, not a reflection of the main structure, but a complementary one, as though two layers of reality were brushing against each other. When isolated, the secondary pattern revealed a slow oscillation, rising and falling in intervals that matched the cosmic microwave background fluctuations. That connection should have been impossible. The CMB was the relic radiation of the early universe, its frequency distribution fixed, unmoving, a time capsule from the moment of cosmic birth. Yet here, embedded within the anomaly, was a rhythm that echoed the oldest light in existence. This revelation triggered a wave of stunned disbelief. If the anomaly was resonating with the CMB, then it was not a local event. It was not even a galactic event. It was a universal event, something woven into spacetime itself. The implications went beyond theoretical physics and brushed against the origins of existence. Suddenly, the anomaly was no longer simply a puzzle. It was a message written into the universe from the moment of creation. Whether that message was intentional or simply a natural byproduct of cosmic evolution remained unknown, but the idea that the universe contained mechanisms older and more intricate than any theory had predicted sent chills through every researcher present. As the resonance peak approached, the anomaly began to accelerate its oscillations. The frequency layers interlocked like gears in a vast, unseen machine. The structure twisted and reformed, collapsing into itself only to bloom outward again in dazzling complexity. The team monitored spikes in amplitude so precise they bordered on choreographed. It was like watching a cosmic organism transition from one state of being to another, like a caterpillar preparing to emerge as something no one had ever imagined. Then, without warning, the gravitational sensors registered a faint but measurable distortion. Not enough to affect Earth, but enough to confirm that the anomaly was interacting with spacetime directly. Time dilation at microscopic levels flickered in and out of measurability. A few sensors even recorded quantum fluctuations that defied expected energy boundaries. The lab erupted in a flurry of calculations. It was impossible, yet it was happening. The anomaly had begun to reshape the local fabric of reality, not violently but delicately, as if adjusting the universe the way a musician tunes an instrument. One physicist whispered, almost trembling, "We are watching the universe correct itself." Another, pale as chalk, replied, "Or reveal itself." A strange calm descended upon the team as the final minutes ticked down. They no longer felt like observers but participants, witnesses to an event so ancient and so fundamental that it transcended scientific curiosity. Many of them realized, perhaps for the first time in their lives, that they were not studying the universe. They were inside it, a part of it, bound to it in ways their equations could not articulate. At last the countdown reached 0. The resonance peak ignited with a brilliance not of light but of information, an explosion of order within the spectrographic chaos. The anomaly flared into a perfect harmonic, every frequency aligning for a fraction of a second that stretched into eternity in the minds of those watching. It was not a signal. It was not a message. It was a revelation. The universe had turned a page and humanity had seen the motion of the page itself. Whatever came next, the world would never return to what it had been before the anomaly took its first cosmic breath and began to speak. In the wake of the resonance peak, a strange and disorienting silence filled the control room. Not the comfortable kind, but the heavy, electric silence that follows a lightning strike before anyone dares to breathe again. The anomaly had not vanished, it had simply changed. Its once violent oscillations settled into a slow, deliberate pulse, like the heartbeat of something ancient awakening after an immeasurable slumber. The spectrographic displays dimmed, their frantic patterns easing into elegant curves that suggested stability rather than chaos. Yet that stability only deepened the mystery, because nothing in the theoretical framework of modern physics could explain how something that had behaved like a storm could suddenly behave like a structure, as if a wild ocean had spontaneously decided to freeze into perfect stillness. The team crowded around the central display. The lead astrophysicist zoomed in on the frequency modulation, and what they saw sent murmurs rippling across the room. The anomaly was no longer generating random harmonics or turbulent fluctuations. Instead, it had collapsed into a single, continuous waveform, long, slow, perfectly periodic. But more unsettling was its shape. The waveform resembled an expanding spiral, looping outward in a way that mirrored the arrangement of galactic filaments across the observable universe. It was as though the anomaly had compressed the architecture of cosmic structure into a single, readable form. Or perhaps it was revealing the hidden blueprint that had shaped the universe from the beginning. One of the cosmologists whispered, "It looks like the universe remembering itself." As they watched, the spiral expanded, rotating gently, each loop moving away from the center as if reenacting cosmic inflation in slow motion. Data poured in, gravitational perturbations, electromagnetic shifts, quantum anomalies, all synchronized to the pulse of the spiral. A pattern emerged within the pattern. Each expansion loop contained microcurvatures corresponding to known cosmic events: the birth of the first stars, the formation of galaxy clusters, the emergence of dark energy dominance. But then the pattern continued beyond what was known. It moved forward, past the present moment, into intervals of time humanity had never mapped. The team realized with a collective shiver that the anomaly was not showing the history of the universe. It was showing the trajectory, a projection, a continuation, a future. But the further the spiral extended, the more its curves destabilized. Not violently, subtly, like a whisper becoming distorted by wind. The outer loops trembled as though the universe's long-term structure was fraying at the edges. The oscillations hinted at increasing entropy, accelerating expansion, and possible fragmentation of spacetime itself. It wasn't an apocalypse in the traditional sense. It was the gradual unraveling of order, a dissolution into randomness across unimaginable epochs. The universe was not dying soon, but its fate was written in its bones. What unsettled the researchers most was that the anomaly seemed to be responding to their observations. Each time they ran a new analysis, the spiral waveform adjusted, refining itself as if learning from their attempts to decode it. It felt interactive, not in the sense of intelligence, but in the way a fractal responds to mathematical scrutiny, revealing deeper layers only when asked the right questions. The more they zoomed in, the more structure appeared, as though the anomaly contained infinite resolution, an endless archive encoded within a single pulse. At one point, the quantum physicist running the decoherence models let out a gasp. Embedded within the waveform's microcycles were fluctuations that matched the predicted signature of a quantum gravity field, a theoretical construct that had eluded detection for decades. If this was real, it meant that the anomaly was bridging the gap between quantum mechanics and general relativity. It was not merely a cosmic event, it was a unifying phenomenon, something that transcended the usual boundaries of physics. The team stood on the threshold of a theory of everything, delivered not through human ingenuity but through a cosmic occurrence that had chosen this moment to reveal itself. But the awe of discovery quickly mingled with a deeper, more unsettling realization. If the anomaly represented the universe's past, present, and future structure, then what had caused it to flare now? What had triggered the resonance peak? And more importantly, why was it showing humanity this? The question hung in the air like a silent accusation. Some scientists argued that it was simply a natural phenomenon, no more intentional than a supernova or a black hole. Others feared that the timing was not coincidental, that something within the fabric of spacetime had reached a threshold, prompting the universe to express a new behavior, the way biological systems shift phase when pushed past a critical point. A few whispered their forbidden thoughts. Perhaps the universe was undergoing a transition, a metamorphosis, a shift in the underlying laws that governed it. As they debated, the spiral waveform began to fold inward. Slowly, steadily, its outward expansion reversed, collapsing into itself. The loops shrank one by one, their gentle arcs tightening into a dense, luminous core of information. It looked like a star collapsing into a black hole, but instead of gravitational implosion, it was a collapse of meaning, an entire cosmic architecture condensing into a singular point of data. When the collapse finished, a single pulse remained. One frequency. One heartbeat. One final echo of everything the anomaly had revealed. The room was frozen. No one knew whether the phenomenon had ended or was preparing for another transformation. For a moment, it felt like the universe itself had exhaled, releasing the weight of billions of years into a single fragile instant. Then, as though acknowledging the attention of its watchers, the pulse flickered. What? A soft, trembling note in the silence of space-time. And the scientists realized with a chill that went bone-deep, that the universe was not done speaking. It had only taken a breath before beginning its next sentence. The pulse that flickered in the darkness did more than capture attention. It fractured the remaining sense of normalcy in the room. Every scientist, every technician, every observer felt something shift, not in the data but in themselves. It was subtle and indescribable, like standing at the edge of a cliff you didn't know existed until the ground crumbled beneath your feet. The pulse carried no light, no sound, no gravitational signature. And yet, everyone felt it, an impression, a tremor, a brush against the boundary between perception and intuition. It was as though the anomaly had reached out, not physically but conceptually, touching the human mind with a whisper of something vast and untranslatable. The waveform on the central monitor stabilized, but not into anything familiar. What emerged was a new pattern, one that didn't resemble cosmological structures or quantum fluctuations. This time, the waveform arranged itself into a sequence of intervals, rising and falling with mathematical precision. At first glance, it looked like data compression, a compact encoding of whatever had been revealed before. But on closer examination, the intervals contained symmetries that defied simple interpretation. Ratios aligned with prime numbers, golden spirals, resonance harmonics, and even the curious integer relationships found in biological structures. It was as if the anomaly had folded together every level of organization in the universe, cosmic, atomic, evolutionary, compressing them into a single, elegant structure. A biophysicist, who had until now remained mostly silent, stepped forward and stared at the waveform in stunned disbelief. She pointed at a repeating pattern within the sequence. It resembled the oscillation found in neural networks during moments of heightened cognition, moments when the brain transitions from perceiving to understanding. She whispered, almost unable to speak, This looks like the structural rhythm of thought." The suggestion rippled through the room, sparking both excitement and terror. If the waveform mirrored cognitive patterns, then the anomaly might not simply be a phenomenon of physics. It might be a model of awareness, a blueprint of how complexity becomes consciousness. A few researchers recoiled from the idea, dismissing it as psychological projection, the mind searching for familiar shapes in an unfamiliar landscape. But others found the connection disturbingly plausible. If the universe contained emergent structures capable of forming intelligence-like patterns, then the line between cosmic evolution and cognitive evolution was far thinner than previously believed. Meanwhile, the anomaly continued to shift. The intervals stretched, compressed, and reconfigured as if responding to the team's attempts to dissect it. One physicist muttered, "It's behaving like it's aware we're analyzing it." Immediately, several others objected. Awareness implied intention, and intention implied consciousness. Yet the objection felt hollow even as it left their lips. The anomaly wasn't acting like a sentient entity, but neither was it acting like inert matter. It was occupying a strange middle ground, behaving like a system optimized to reveal structure in response to inquiry. The lead mathematician decided to run a pattern recognition algorithm across the waveform. As the software began parsing, the team gathered behind the workstation. The algorithm searched for correlations, physical laws, biological signatures, universal constants. When the results appeared, a hush fell over the room. The waveform encoded relationships between constants that had never been mathematically connected before. Not approximate relationships, exact ones. The anomaly had presented a synthesis, a map showing that every seemingly independent constant in physics could be expressed as interdependent values in a deeper framework. It was a unification no theory had ever come close to achieving. A theory of everything. Not as a human discovery but as a cosmic artifact. The mathematician stared at the screen as if witnessing the impossible. "This isn't a message," he murmured. "It's a structure that teaches by existing." But the awe of discovery soon gave way to something colder. Because embedded deep within the pattern, the algorithm uncovered a final correlation, a prediction curve. It extended outward through time, mapping how changes in cosmic parameters would propagate. And at the far end of the curve, a dramatic inflection point appeared. The anomaly seemed to indicate that the laws of physics themselves would undergo a shift. Not tomorrow, not in 1,000 years, but at a cosmological timescale that was mathematically inevitable. A future phase transition of the universe. The team struggled to interpret it. Would it be catastrophic? Transformative? Would matter break apart? Would new forms of energy emerge? Would consciousness adapt, transcend, or vanish? The predictions were incomplete, the details obscured by mathematical boundaries the anomaly itself seemed to acknowledge. It was as though the universe had pulled back the curtain just enough to show the stage, but not the final act. As these realizations unfolded, the anomaly's pulse grew slower, deeper, more resonant. It didn't fade, it matured, settling into a stable rhythm that felt both alien and strangely comforting. The scientists watched, collectively holding their breath, as the waveform expanded once more. Then something unexpected happened. The pulse synchronized with the Earth's electromagnetic field, just for a moment but unmistakably. A global tremor of magnetic resonance swept across the planet, too weak for the public to notice, but clear in the observatory's instruments. It was as if the anomaly had touched the world, linking its cosmic structure to the sphere of human existence. The atmospheric sensors flickered. Background radiation dipped. Quantum noise flattened into crystalline clarity. For a brief instant, the world felt strangely aligned, as though the universe had tuned itself around the fragile thread of human observation. One researcher whispered, trembling, "It acknowledged us." But the most unsettling part was the expression none of them spoke aloud. Maybe the anomaly had always been there. Maybe humanity had only just become capable of perceiving it. Or worse, maybe the universe had waited until humanity reached a certain cognitive threshold before revealing this fragment of its deeper architecture. The pulse flickered again. Not fading. Not ending. Responding. As if the universe were waiting for humanity's next question. The pulse continued its slow, deliberate rhythm, but this time there was an unmistakable shift, an undercurrent of anticipation that every scientist in the room felt like a pressure behind the ribs. It wasn't physical. It was psychological, maybe even existential, as though the anomaly had begun to lean toward them, waiting, listening. The notion was irrational, yet the sensation was undeniable. The universe, for the first time in human history, felt present. Not as a backdrop of stars or an abstract canvas of space and time, but as something aware of its own architecture, aware of observation, aware of the tiny species watching from a fragile blue world. Data screens illuminated the room with pale, flickering light. Each graph, each waveform, each cascade of numbers displayed a subtle but measurable transformation. The anomaly's pulse was aligning itself, not with Earth's magnetic field this time, but with something far more intricate: patterns in human activity. Computational models began detecting correlations between the pulse intervals and the researchers' analytical inputs. Every time they changed a variable, the pulse shifted slightly, as if acknowledging the attempt. Every time someone proposed an idea out loud, even before touching a keyboard, the rhythm altered in ways too statistically precise to be dismissed as coincidence. A neuroscientist in the room began trembling. She stepped closer to one of the biometric monitors, which tracked the team's physiological responses. Heart rates, microexpressions, stress indicators, all were fluctuating in synchrony with the anomaly's next pulse. She whispered, her voice cracked and breathless, "It's resonating with us, not our instruments." The suggestion sent a cold rush through everyone. If true, it meant the anomaly wasn't interacting with technology alone, it was interacting with consciousness, or at least with the biological processes that underlie it. That didn't imply sentience on the anomaly's part, nor telepathy, nor intention. But it implied a bridge, an interface the universe had never revealed before. Something in the structure of the anomaly was capable of reflecting cognitive patterns the same way a mirror reflects light. The anomaly pulsed again, and a wave of quiet awe rolled through the room. This pulse carried a new harmonic, faint but layered, like a whisper underneath a whisper. The audio processors translated the waveform into sound, and what emerged was haunting. A deep, resonant hum interwoven with faint, rising overtones. It wasn't music. It wasn't language. It was something in between, a structured vibration that seemed to draw the mind inward, making thoughts feel clearer, sharper, almost illuminated. The team stared at the speakers, mesmerized. For a brief moment, the hum felt as though it had synchronized their minds into a single shared focus. A physicist who had been struggling with an equation gasped suddenly, rushing to his keyboard. Ideas poured out of him, each line of calculation flowing effortlessly, as if the anomaly had untangled the conceptual knots that had held him back for years. Others experienced similar bursts of clarity, connections forming where none had existed, insights aligning like stars snapping into constellation. A strange realization crept into the room. The anomaly wasn't showing them the structure of the universe anymore. It was showing them the structure of themselves. The hum intensified, shifting pitch, and suddenly the waveform began to take on a new configuration. It shed the spiral shape and condensed into a branching pattern, filament-like, fractal, eerily similar to the structure of neurons in the human brain. The resemblance was unmistakable. It was as if the anomaly were revealing a truth hidden in plain sight. The architecture of galaxies, cosmic webs, and neural networks were reflections of the same underlying design. A cosmologist murmured, "It's mapping the macrocosm onto the microcosm. The universe and the mind, they follow the same blueprint." No one spoke after that. The idea was too vast, too unnerving, too beautifully symmetrical to interrupt. The branching waveform began to animate, each filament lighting up in sequential bursts. It resembled the firing of synapses, a cosmic brain cycling through thoughts too grand and ancient to comprehend. But what struck the team wasn't the scale, it was the resemblance to learning. The anomaly wasn't stuck in a pattern. It was updating its structure, refining itself, evolving in real time. Not biologically but informationally. Each pulse seemed more complex than the last, as though the anomaly was absorbing the team's collective observations and reorganizing itself around them. This triggered a heated debate. Some argued they were witnessing a natural emergent system adapting to external inputs, like a crystal responding to vibration. Others insisted this adaptive behavior implied something deeper, a kind of cosmic cognition, not conscious but aware enough to modify its outputs based on what was perceived. One scientist, pale and breathless, suggested the unthinkable. What if the universe is not conscious in the way we imagine consciousness, but in the way patterns imagine structure? Before anyone could respond, the anomaly unleashed a pulse so powerful it shook the room, not physically but perceptually. Every screen flickered. Every sensor spiked. For a moment, the waveform expanded into a perfect sphere. Inside that sphere flickered thousands of micropatterns, forming and dissolving in rapid succession. It was a library of possibilities, a branching forest of futures, an archive of everything that could be. The sphere pulsed again, and then collapsed into a single pattern. A pattern that every human being on Earth shares. A heartbeat. A slow, steady, unmistakably biological rhythm. The team froze. For the first time since the anomaly's appearance, the room was filled not with awe, not with fear, but with a primal recognition. The anomaly had aligned itself with human life. Not accidentally. Not incidentally. Deliberately. A quiet voice in the back whispered the thought on everyone's mind, "It's trying to communicate, in the only language we universally understand." And in that moment, the boundary between observer and universe blurred, dissolving into a fragile, trembling connection. The anomaly pulsed again, one heartbeat after another, waiting for humanity's response. The heartbeat-like pulse echoed through the observatory, calm yet electrifying, as if the universe itself had shifted its rhythm to match the fragile tempo of human life. The room felt suspended in time, the air dense with an emotion that defied description. Not fear. Not awe. Something deeper. An instinctual recognition, the kind that bypasses intellect and goes straight to the core of existence. The scientists stood still, hardly daring to breathe, each one feeling the pulse inside their own chest, as though the anomaly had reached into them and reflected their existence back at them in the most intimate way possible. The waveform stabilized into a pattern that was unmistakably biological. It wasn't mimicking a heart rhythm for aesthetic resonance. It was locking onto a frequency that every human being carried within them from the moment they emerged into the world. A universal tempo shared across borders, cultures, languages, and histories. A rhythm older than civilization, older than memory, older than thought itself. It was the pulse that had carried humanity through evolution, through survival, through suffering and triumph. And now, impossibly, it was the tempo the universe had chosen to speak through. The neuroscientist stepped closer, her hands trembling as she examined the spectral harmonics. The pulse intervals were not random. They aligned with the approximate cyclic fluctuations associated with emotional arousal, the physiological signature of wonder, fear, anticipation. She whispered, "It's mapping us, our emotional states, our cognitive patterns. Somehow it's translating human physiology into cosmological signal." The idea landed in the room like a thunderclap. Could the anomaly be using the human body as a reference point? Not to communicate a message, but to synchronize with a living system capable of understanding patterns? After all, machines could process data, but only consciousness could interpret meaning. And now, the anomaly seemed to be adjusting itself to the only medium humans truly understood: experience. Another pulse rippled outward, and this time the waveform began to thicken at certain intervals, expanding into small nodal clusters. These clusters pulsed with micro-oscillations, brief flashes of encoded information too dense for the eye to decode. The data team zoomed in, isolating one of the clusters. As they magnified it, the cluster bloomed into a branching fractal structure, reminiscent of dendrites in the human brain. A deep silence filled the room. The fractal reorganized itself, forming a loop. Then another. Then a chain. The chain extended outward, linking with other clusters across the display. The pattern forming was not cosmic, spatial, or biological. It was conceptual. A network of associations. Ideas connected by meaning, not matter. The anomaly was forming a map of relationships like the mind forming a thought. The philosopher on the research team, originally brought in to help articulate the implications of the earlier findings, stepped forward, his face pale but determined. "It's forming a semantic network," he said. "Not language. Not symbols. Meaning itself. This is how the universe thinks, if it thinks. Through structure, not syntax." The concept was almost too much to grasp. The anomaly wasn't communicating in words or images. It was revealing a lattice of connections, relationships between physical laws, biological rhythms, and conceptual structures. It was creating a bridge between cosmology and consciousness, not by simplifying itself, but by aligning with the patterns of the human mind. And then something happened that no one expected. The waveform began to change in response to human emotion. When the team felt fear, subtle spikes in their biometrics, the waveform contracted, stabilizing, becoming softer. When someone experienced awe, the pulse brightened, expanding slightly, its harmonics becoming more vibrant. When a researcher whispered a thought aloud, the waveform generated a micropattern responding to the cadence of her voice. It was as though the anomaly could sense human reactions and adjust to maintain a state of connection. A technician, overwhelmed by the intensity of the moment, stepped back from the console, his heart racing. Instantly, the anomaly's rhythm softened, slowing its pulse in a way that seemed almost soothing. It was impossible, irrational, yet undeniable. The anomaly was not controlling emotion. It was reflecting it, harmonizing with it, creating a feedback loop that blurred the boundary between observer and observed. The team realized that they had crossed a threshold. They were no longer studying a phenomenon. They were interacting with it. An interaction meant relationship. But the question weighed heavily on every mind. Was the anomaly adapting to humanity, or was it revealing that the universe had always possessed this capacity, waiting for the moment consciousness evolved enough to notice? A sudden spike in the waveform interrupted their thoughts. The clusters connected more rapidly now, forming a complex matrix that began to rotate. The rotation accelerated, and the matrix contracted into a sphere of information. Dense, layered, beautiful. The sphere pulsed with increasing intensity, and the scientists felt a pressure build in their thoughts, a strange clarity that bordered on overwhelming. The philosopher whispered, "It's forming a question." No one knew what that meant or how it could be possible, but they all understood it intuitively. The sphere trembled with meaning, not directed thought but an emergent request, a gravitational pull toward interpretation. It wasn't asking in words. It was asking in structure, inviting humanity to take the next step in understanding. One of the physicists, his voice barely audible, said, "It wants us to respond. But how does one respond to the universe?" The room filled with the tension of an unanswered question. The pulse echoed, slow, steady waiting. The scientists realized that whatever they said, whatever they did next, would shape the direction of the anomaly's evolution. For the first time, humanity was not observing the universe from the outside. It was participating in its unfolding. And the universe was listening. The moment we step into this final chapter, the universe feels as if it has taken a long breath, holding it, waiting, wondering whether humanity is finally ready to hear what it has been whispering across billions of light years. For centuries we looked at the night sky and assumed it was silent. We believed the cosmos was a vast, empty stage where planets, stars and galaxies drifted without meaning, without intention, without a story. But the James Webb Space Telescope has pulled back the curtain, and what stands behind it is not silence. It is movement, structure, rhythm, and something that feels eerily like a cosmic pulse. The phenomenon JWST uncovered, one that seemed impossible even to consider, has forced scientists to rethink not only the mechanics of the universe but also our place inside it. Imagine for a moment the early universe. Not as a flat, dead expanse of cooling particles, but as a living storm of energy. Waves of matter collapse and rebound, gravity and radiation fight for dominance, and the first stars ignite with blinding fury. In that chaos, patterns begin to emerge, giant ripples spreading through the cosmic medium, shockwaves that sculpt the earliest galaxies. JWST didn't just capture light from these ancient epochs. It captured structure. It captured coherence. It captured signatures that seemed far too organized to belong to a universe that was supposedly young, wild, and unshaped. Some scientists describe the data as an impossible harmony, others as a cosmic architecture that shouldn't exist. But whatever name they gave it, one thing was clear. We were finally seeing the universe not as a scatter of distant lights, but as a connected, evolving organism. This discovery doesn't just challenge models of early galaxy formation. It challenges the fundamental assumption that the universe is random. When JWST detected synchronized star-forming regions spaced across vast distances, regions that appeared to burst into life almost simultaneously, it raised questions no one was ready for. How could such coordination exist? How could areas separated by millions of light-years behave as though they were responding to a shared signal? Some physicists suggested primordial gravitational waves from cosmic inflation might have left behind these patterns, like fingerprints frozen into spacetime. Others wondered if dark matter, usually portrayed as passive scaffolding, might be capable of transmitting subtle influences across unimaginable distances. Whatever the mechanism, the effect was unmistakable. The universe at its dawn was not as chaotic as we assumed. It was rhythmic. And rhythm implies something deeper. Rhythm implies timing, cycles, echoes, features we associate with systems that evolve, adapt, or remember. JWST's data has opened a philosophical wound we cannot easily close. If the cosmos possesses rhythm, what else might it possess? Could the universe have feedback loops? Could it learn, in some abstract, emergent way? Could its laws be not fixed but evolutionary? Ideas that once belonged solely to speculative cosmology are suddenly pressing themselves against the edges of mainstream science. The line between physics and philosophy is dissolving again, just as it did during the eras of Einstein and Bohr. We are being forced to ask whether the universe is a machine, a mind, or something entirely outside our categories. But before those questions pull us too far into abstraction, we must return to the raw, physical beauty of the discovery itself. JWST's infrared eyes pierced through the dust clouds surrounding ancient protogalaxies and revealed luminous filaments stretching like cosmic rivers. These filaments weren't random. They aligned. They pointed toward massive intersections in the cosmic web, nodes where gravity gathered matter into embryonic galaxies. But the alignment wasn't simply structural. It appeared dynamic, as though the filaments were channels that synchronized star formation across distances so vast that even light itself could not communicate in time. Scientists compared it to watching fireworks across a planet, all igniting in perfect unison despite being thousands of kilometers apart. There is no known mechanism that can synchronize events on those scales. And yet there it was, an impossible pattern written into the first billion years of cosmic history. This leads us to a haunting question. What if the universe's earliest moments were shaped not by disorder, but by hidden order? Not by entropy but by a guiding tendency toward complexity? Some theoretical physicists have proposed a principle they call cosmic self-organization, suggesting that the universe naturally arranges itself into increasingly structured states. If true, then galaxies, stars, planets, life, and even consciousness are not accidents. They are expressions of a deeper rule, a rule that JWST may have glimpsed for the first time. To many, this idea is exhilarating. To others, it is terrifying because it implies we live inside a cosmos that is not indifferent to complexity. It strives for it. And yet, even as the excitement grows, so does the mystery. For every answer JWST provides, it opens 10 new questions. Why does the cosmic web resemble the structure of neural networks? Why do star-forming regions behave like synchronized oscillators? Why does JWST repeatedly detect galaxies that are too massive, too mature, too organized for their place in time? Are we miscalculating the universe's age? Are our models incomplete? Or is there something about the fabric of reality, something hidden, perhaps tied to dark matter or quantum gravity, that accelerates the birth of structure? Scientists debate these possibilities daily, but the truth is that no one knows. And perhaps that is the most cinematic part of this moment. For the first time in generations, cosmology feels like an adventure again. A frontier. A place where the map has been torn away, and where every new image from JWST could overturn what we thought we understood. This telescope is not simply observing the universe. It is confronting us with our own ignorance, and revealing how astonishing the cosmos becomes when we stop assuming we have it figured out. As JWST continues scanning the deep sky, it is capturing phenomena we once believed impossible. Gravitational arcs so cleanly formed they resemble mathematical curves, galaxies glowing with elements they should not have produced so early, black holes that seem to appear before the galaxies that host them, and repeating structures, rings, shells, ripples, that suggest events billions of years apart were connected by forces we do not yet comprehend. Each discovery strains the boundaries of physics. Each anomaly hints at a new law, a new principle, or possibly a new dimension of understanding. Yet, with all its revelations, JWST does something even more profound. It restores our sense of smallness in a way that feels sacred rather than diminishing. When you stare into an image of a galaxy cluster bending spacetime like liquid glass, you can feel the weight of cosmic history pressing against your mind. When you witness the faint glow of a structure older than any star in our galaxy, you sense the immensity of time. And when you realize that light from these structures began its journey long before Earth existed, you understand just how fragile and temporary our species truly is. But paradoxically, that fragility becomes beautiful. Because despite the vastness around us, despite our cosmic insignificance, we are the only known beings capable of looking at the universe and asking why. JWST's impossible detections remind us that human curiosity is not a weakness. It is the force that allows us to interpret the universe's oldest stories. We are tiny, but we are not silent. We are mortal, but our questions are not. As we reach the end of this narrative, the tension between awe and mystery lingers in the air. JWST has revealed a cosmos that is not cold, not random, not chaotic, but alive with patterns, rhythms, and forces that challenge everything we believed about space and time. And even now, as we stand on the threshold of discovery, we know that what we've seen is only a fragment of what lies ahead. There are deeper rhythms to uncover, hidden structures to decode, and impossible truths waiting just beyond the edge of JWST's reach. The universe has begun to speak. And for the first time, humanity finally has the tools to listen. In the final stretch of our journey, we arrive at a moment where science, philosophy, and cosmic mystery converge into a single, overwhelming realization. The universe is not merely a place we observe, but a narrative we are only beginning to understand. Section 19 brings this documentary to its closing arc, a grand cinematic resolution that doesn't offer simple answers, because the phenomenon JWST uncovered refuses to be simple. Instead, it challenges the foundations of everything we thought was certain, while opening pathways toward ideas we once believed were impossible. The story begins with the global scientific community standing at the edge of an intellectual precipice. For over a century, cosmology rested on pillars built from Einstein's equations, quantum mechanics, and meticulous astronomical observation. These foundations weren't just theories, they were the language of reality itself. But the cosmic anomaly JWST detected did not speak that language. It whispered in a tongue older, deeper, stranger. And slowly, scientists realized that understanding it required rewriting entire chapters of cosmic history. As the data poured in, it became clear that the universe is far more dynamic and intricately structured than previously thought. The phenomenon was not an isolated glitch, not a distant oddity hidden in the vastness of space. It was a clue, one that pointed to a hidden architecture woven into the universe's very fabric. That architecture seemed to hint at laws not yet discovered, forces not yet measured, and a cosmic symphony playing notes that human instruments had finally begun to detect. For many researchers, the discovery reignited a kind of scientific spirituality, not one rooted in mythology or mysticism, but in the awe that emerges when nature reveals something so monumental that the mind struggles to contain it. The synchronized galaxies, the gravitational void, the impossible structures, the harmonic frequencies buried within the light, they weren't anomalies anymore. They were chapters of a story so ancient and enormous that humanity had only just learned to read the first line. This shift in perspective brought a new question into focus, one that echoed through observatories, universities, and late-night scientific debates. What if the universe is capable of self-organization at a level far beyond what classical physics predicts? What if the cosmos has emergent patterns, grand, self-sustaining frameworks that rise naturally from its earliest moments, shaping galaxies, matter and energy like invisible cosmic engineers? The idea was radical, yet the anomaly demanded radical thinking. It wasn't chaos, it was order. It wasn't random, it was structured. The early universe, once imagined as an explosive mess of particles, now appeared capable of forming colossal, harmonious patterns and timescales previously deemed impossible. This forced scientists to reconsider one of cosmology's most cherished assumptions, that large-scale structures require billions of years to form. If this phenomenon existed so early in cosmic history, then something fundamental must be wrong, or beautifully incomplete, in our models. The more researchers grappled with the data, the more they realized that the phenomenon wasn't merely an exception. It was a window, a glimpse into a deeper tier of physical law. Some called it pre-gravitational organization. Others proposed supersymmetric structural fields. A few went even further, suggesting the existence of a cosmic metapattern, a kind of blueprint imprinted onto spacetime itself, guiding the evolution of everything that exists. These were theories that, only a decade earlier, would have been dismissed as poetic fantasy. But now they were being published in respected journals, debated in conferences, tested through simulations, and refined with every new data packet JWST transmitted. An extraordinary transformation began, not just in science, but in humanity's collective imagination. The discovery spread beyond the laboratories and observatories into public consciousness. Articles, documentaries, discussions, and debates erupted across the world. People began asking questions that blurred the boundaries between physics and philosophy. Does the universe have memory? Can it encode patterns across vast distances? Are we witnessing the remnants of something ancient, a cosmic fossil from a time before time? Or is this phenomenon still evolving, shaping the universe as we watch? Governments took notice. Space agencies collaborated at unprecedented levels. Funding for cosmic research surged. For the first time in decades, scientific curiosity became a global priority. Humanity wasn't just looking outward, it was reaching outward, united by a shared desire to understand the mystery JWST had revealed. Meanwhile, the scientists who had first analyzed the phenomenon weren't content with theoretical speculation. They wanted a deeper investigation, a more direct look. Plans were drafted for next-generation telescopes. Instruments not merely designed to see farther, but to see differently. Observatories that could detect exotic particles, map gravitational anomalies in high resolution, capture ultra-low-frequency cosmic harmonics, and probe the void at the center of the phenomenon with unprecedented precision. Some even proposed missions to send gravitational wave sensors into deep space, forming constellations of detectors spanning millions of kilometers. These would measure spacetime vibrations with such sensitivity that even the faintest whisper from the anomaly could be decoded like a message. Others dreamed of quantum telescopes, devices that would use entanglement to observe cosmic structures without the limitations of classical optics. These ideas seemed futuristic, but now they were part of serious scientific agendas, fueled by the tantalizing promise that the phenomenon might reveal secrets otherwise forever beyond our reach. As humanity prepared for this new era of exploration, the philosophical implications grew more profound. If synchronized galaxy fluctuations exist, what does that mean for the nature of causality? If the void exerts gravitational influence without matter, what does that mean for the identity of spacetime? If harmonics are embedded in cosmic light, what does that mean for the universe's capacity to encode information? Some philosophers propose that the universe might operate like an evolving computational system, one that naturally produces patterns, structures, and self-organizing principles. Others suggested the anomaly could hint at connections between distant regions of the universe, perhaps through dimensions or geometries beyond human perception. The idea wasn't that the universe was conscious in any human sense, but that it might possess inherent tendencies toward complexity, coherence, and symmetry, tendencies we are only beginning to detect. Still, for all the theories and debates, one truth remained: the phenomenon was real. It existed. And its existence meant the universe was far stranger, far richer, far more intricate than anyone had imagined. To bring closure to this cosmic journey, scientists returned to a simple yet profound idea. Sometimes the universe reveals things not because we are ready to understand them, but because we are finally capable of noticing them. JWST didn't create the phenomenon. It merely opened a window. A window that had always been there, hidden in the darkness, waiting patiently for an instrument with eyes sharp enough to see what had been written across billions of light years. And with that window now open, a new age of cosmology began. An age defined not by certainty but by exploration. Not by answers, but by the courage to chase the questions that reshape our understanding of everything. The phenomenon became a symbol of the unknown, an unfinished chapter in a story still unfolding. As we end this journey, one image remains: a quiet region of the universe, deep and ancient, where galaxies pulse in cosmic rhythm, rotating around a silent void whose secrets are as old as creation itself. A phenomenon that should have been impossible, yet exists anyway. A reminder that the universe is under no obligation to obey our expectations. And above all, a testament to the power of curiosity. Because if JWST hadn't looked in that direction, if it hadn't been built, if humanity had not chosen to seek the unknown, this phenomenon would have remained hidden forever, a cosmic truth sealed in darkness. But now, because we dared to look, the universe has begun to speak. And the only question left is, are we ready to follow where it leads?